Hello, AP Stat student. So today we are talking about Chapter 5.1, Randomness, Probability, and Simulation. We're doing the CFU for 5.1. So Concept 1, the idea of probability. So today, in this section, you should be able to interpret probability as a long-run relative frequency. So first question. The probability of drawing a jack, queen, or king from a standard deck of playing cards is approximately 0.23. Now, I don't know if you know how to find the 0.23, and it's actually pretty simple. So, because there are four decks, one deck of cards, four suits in a deck, and each suit has a jack, it has a queen, it has a king. So 3 times 4, that makes 12 cards. So 12 divided by 52, that is about 0.23. So explain what this probability means in the context of drawing from a deck of cards. So if you think about probability, right? If you draw cards, you are actually going to repeatedly draw the cards, as many cards as you can, but you draw it with replacement. So you got to put it down in the statement. If you were to repeatedly draw cards from the deck with replacement, all right? So because it actually applies in the long run. So from a shuffle deck, you would draw a jack, a queen, or a king about. Now, this is important. I highlighted here about, because you're never going to be exact, would you? Right? So about 23% of the time. Right, part B. Does this mean if we repeatedly draw a card, replace it, shuffle, and draw again 100 times, that we will draw a jack, a queen, or a king 23 times? Why or why not? So do you think we'll get exactly 23? No, of course not. We're not going to get 23, right? We would expect, right, to draw a jack, a queen, or a king about, right? This is important, about, because we don't know for a fact. Nothing is guaranteed here. About 23 times out of 100, but we are not guaranteed exactly 23. All right, so now let's look at concept 2 on simulation. Now, this is a big one. So you should be able to use simulation to model a chance behavior. Okay, so let's read through this. A popular airline knows that in general, 95% of individuals who purchase a ticket for a 10-seat commuter flight actually show up for the flight. In an effort to ensure a full flight, the airline sells 12 tickets for each flight. Design and carry out a simulation to estimate the probability that the flight will be overbooked, and that is, more passengers show up than there are seats on the flight. So you need to look at what's been given to you. So 95% of individuals who purchase a ticket actually showed up. So now we need to assign numbers, right? We need to use the chance process, the chance behavior process, and we need to assign numbers. So what can we do? So we're going to let the digits, right, 0, 1 to 95. Now notice that why use 0, 1 and not just use 1? Because we have to follow. If we are using 2 digits, then the first digit, even though it's a 1, it has to follow a 0, 1. Okay, 0, 1 to 95, right? And let that represent a passenger showing up for the flight. So if you randomly put 0, 1 to 95, so you put 95 pieces of paper that has numbers 0, 1 and 0, 2, 0, 3, 0, 4, 0, 5, all the way to 95. You put it in a hat and randomly pick a number. And if you have something like, say, 70, that means that passenger does show up, because 70 represents a passenger showing up for the flight. So how about passengers who didn't show up? Then it goes to follow. It starts from 96 and all the way to 00, which represents 100, right? Because 95%, you're talking about 95 out of 100. Okay, so 96 to 00 represent a no-show. So, when I reread the question, and it says 95% of the individuals who purchase a ticket for the 10-seat commuter flight actually shows up for the flight. Now, I wanted to give you another scenario. So anybody who's going to show up at the gate, he or she, that person, there's a 95% chance that the person could have bought a ticket or doesn't have a ticket. Do you see how this can be flipped around and look at it from a different angle? So, right, so you select, actually, what I was trying to do is this. So you select 12 two-digit numbers, right, from a line of random number table, right? And it will be given. You just have to, just choose 12 sets of 2 digits, and they need to be together side by side. You just have to let the digits run from left to right. So, or a random number generator, which we can simulate that using the calculator, okay? So I'm going to show you how to use the calculator. All right, so, you can go to math, and then you go to PRB, probability, and then if you scroll down to number 5, it says random integer. So, and the smallest number I want is a 1. It should start with a 1. See that I do not need a 0, 0 or a 0, 0, 1. I just need to put just 1, right? 1, and then 100, right? Between 1 to 100, and I want 12. Okay, and then when I press enter, right, and you can see that's only one number, 95, another number, 91, 15, 52, 41. And if you scroll to the right, it shows you the remaining 12 numbers. All right, so from the calculator, I put down the 12 numbers. So 95, 91, 15, 52, 41, 74, 5, 34, 100, 21, 80, and 96. Now, what do those numbers mean? So if you look at it, 95 is a show, right? This person who's randomly picked, he's actually showing up with a ticket. 91 is a show, 15 is a show, 52 is a show, 41 is a show, 74 is a show, 5 is a show, 34 is a show. 100, however, he's a no-show. Then 21 is a show, 80 is a show, and 96 is also a no-show. All right, so I'm showing you a table of random numbers. So if you look at the very first row, now if the first 2 digits is a 36, so that's a show. The next 2 digits, 51, that's a show. 83, right? Side by side, the 2 digits, 83, it's a show. 67 is a show. 77 is a show. 89 is a show. 11 is a show. 60 is a show. 55 is a show. So you count 12 sets of numbers, and then from the 12 sets, you see, you run the simulation to see out of the 12, how many show and how many no show. All right, so ignore repeats, right, until you have 12 numbers selected, either from the random digit table or from the calculator. All right, and count how many times did 96 to 00 show up, right? How many no-shows occur on the random digit table or on the calculator? So previously we had 2 no-show, the one with the 100 and right here, right, 100, which is, let's use a different color, which is right here, and the 96. Right? So if 96 to 00 occurs less than 2 times, or 96 to 00 or 96 to 100 on the calculator occurs less than 2 times, then the flight is overbooked, right? Because we need to have more than 2 no-show for the flights to be, for the flight not to be overbooked. All right? So repeat this procedure 20 times and then determine how many of those 20 trials result in an overbooked flight.